Hey folks, how's it going? I'm running late today. Sorry. Just getting everything set up. So give me a couple of minutes. Give me a couple of minutes. I hope everyone's doing very well. Having a good week so far. For me, it's been a good week. Jumping into a new big feature for jank. Hey, Johnny. You were worried? Sorry. All right, we need a new title. We need a new stream title. Building the jank programming language. C++ closure LLVM. Done. Apart from it being 100 degrees outside? Damn. Yeah. It is not that bad here. But I'm sorry it's that bad there. That's not great. I think it's only like 80 maybe here. It's getting warm. In Seattle, honestly, this year hasn't been so bad. I know obviously other people around the world have had it really rough. It's not been so bad here yet. We'll see. We'll see. We still got a couple months in terms of Seattle weather anyway. All right, so I think we're all set up now. The only thing is I haven't actually done a announcement in my Slack channel. I haven't done an announcement in my Discord. Let me do that. It's getting worse every year. Yeah. Like my hairline. All right. I think we're golden now. Whew. So I'm working on something that I'm not ready to work on stream because it's too exploratory. So I'm going to set that aside for today, and we're going to jump into something that's more concrete that I can actually just hack out, because I don't want to be just digging through like Clang APIs the whole stream trying to figure out how to put things together. But the thing that I'm let me see, do I want to show this? Let me decide if I want to show this. No, I'm not going to show it yet. I'm working on I will tell you, I'm working on error reporting. And so this involves a few things. The first thing is I went through all 853 functional tests that we have. And for all the failing ones, I made sure that they have good source snippets in them. So for example, we have tree tests jank, we have all these files in here, right? And these are all just like all the different operators that C++ supports, and then like on the jank side of things, like functions and arities and recursion and all these things. We're going to make sure that for all of the different failure cases that we have good snippets that actually point at where things went wrong. And so that's good. But there are two other aspects of error reporting that I want to try to tackle, ideally before conch. And one is the handling of runtime errors. And so right now, if you get a runtime exception that's uncaught, so I believe I actually have a file open for this, like this. Actually, let me simplify that even further to just a throw. So if you just have a function foo that throws, and then we just immediately call that, we're going to JIT compile a function foo, and then that function is going to throw. Right now on main, which is what I'm on, we get the uncaught exception, and then this frame right here, frame 4, is blank. And this is the frame that should say foo, and it should say test.jank line 1, everything like that. And then in like the way that Clojure JVM works is, and we can actually do this if we run test.jank with Clojure. Oh, right, because Clojure doesn't allow you to throw just anything, does it? So we have to do like a exception meow? Maybe that would work. Yeah, there we go. So Clojure ends up saying, so this happened at test.jank line 1, right? Now, Clojure knows this, not because it's tracking like which functions it's in at any given time, not because it got the source information from like the code generation of the throw expression. It knows this simply because it takes a look at the stack trace. And if we take a look at the stack trace right here, it takes a look at the stack trace, and it basically just trims out everything at the top of the stack trace until it finds something that looks like user code, and then it's like, okay, that's where this was thrown from. And so if there's any sort of like JVM internals or something like that at the top, it'll trim those out, and then it'll find the or I think compiler internals, it also trims that out, but it'll find the closest looking thing that looks like user code, and then it'll just say, okay, so we're in test.jank line 1, and then it'll assume that that's where we should show the source info from. So Jank's going to do the same thing, except on main right now we don't actually have anything there, right? And so this should show, ideally, this shows the namespace as well as the name of this foo function that we're in, and something that'll be like user foo. And then it should also show test.jank, should say at, like these do, at test.jank colon 1. That does not happen right now. So I have a separate branch where I'm working on that, at least for x86-64, and we'll see. But once we can get that, then we're going to be able to scan through the stack trace, find basically the relevant jank source, and then we're going to be able to show a nice code snippet in there as well. And so that'll be lovely. That's the first part of the additional error reporting work. The second part is for all of the C++ interop stuff that we're doing, like calling overloaded functions and instantiating templates and I don't know what's other interesting stuff where you get neat errors. Overloaded functions and templates are definitely maybe like argument dependent lookup. That still has to do with like overload resolution though. can't think of other examples, right? I think I actually have a note for like for some examples I've thought of this. Member access for private protected things. Yeah, I have these three. Like, I'm trying to identify like what are the most common C++ use cases. But anyway, C++ and Clojure are both known for their awful error messages, and I, with Jank, have tried to really improve upon Clojure's error messages. To the point where let me just do like a jank run test jank form def. What do we got? Like fail qualified, maybe be a good one, right? This is a fucking lovely error message, right? We have a fully qualified symbol here. It's not supposed to be qualified. So we get like an error ID, analyze invalid def. We get a nice error message. The provided var for def must not be qualified. We get a nice code snippet that underlines the exact place where the problem is. Like, that's lovely. If you compare the same thing with what Clojure does, you get, it tells you the file and line, and it says it can't create defs outside of current. Oh, this is actually a separate problem because apparently we need to have an NS in that file before we can create a def. Oh no, that's actually the message that it has. Oh, so the message is actually saying that we're not in Clojure core, and so you can't create a def for some other thing. I wonder if that means that that Clojure actually allows you to have a fully qualified symbol as long as that symbol is qualified to the current namespace. Jank just prohibits you from having a fully qualified symbol at all because that's just not what's supposed to be expected. Anyway, yeah, so this is confusing enough of an error that I didn't even know if it was telling me that something else was wrong. So like we already improve on Clojure quite a bit here, I think. But we're not improving on C++ at all, because when you have something like an overload resolution error, right now we don't give you any info at all. And so let's take, for example, we have, also since I realize I'm in the middle of a pretty long rant, Xhister, let me respond to you. Do you upload all your code and VODs from your stream somewhere? All my code goes to GitHub because that's I'm working on Jank, and all of the code is on GitHub. My VODs do get all uploaded to YouTube. So there's a Jank TV YouTube channel, and I can drop a link to that if you like. There you go. There's a link to the Jank TV channel. So yeah, all the videos get uploaded to that when I'm done. I don't snip them or anything. I just do like, here's a 4-hour upload. They take a long ass time, and it's not because I'm slow. I click the export button as soon as I'm done with the stream, but it generally takes like 24 to like 30 hours for it to actually be uploaded to YouTube. And it goes straight from the Twitch servers to the YouTube servers, but it just takes a long ass time to upload like a 4-hour video and encode it and everything like that, whatever YouTube does. So yeah, expect like a day or two lag on that. But yeah, so let's take an example of something like toString, right? So toString has a whole bunch of overloads. So you have one that takes an int, long, unsigned, long, and you have floating point stuff as well, right? So assume that we wanted to call standard toString. Now, if we just give it foo, let's put a print line as well. Then we should just be able to run this. I'm not running the right file. We should be able to run this and we get 4. Because in this case, 4 is just going to be an integer. But let's say that we do a string, a C string. So right now, what we're going to get is, okay, well, there's no matching call to the toString function. And then we end up saying that the types of all the arguments. So argument 0 has the type of a C string. So this is an array of 2 characters, one being the 4 and then the other one being the null byte. And then we don't provide any additional info. Whereas if you were to do this in C++, so we were to include, what's that? A string. It's in string. So that's in string, and we'll just do IOStream, and we'll do main, and then we'll do a cout of toString for, and if I do this, this is what C++ gives us. So it underlines the call to toString, right? Just like we did. And it says there's no matching call, So we also say no matching call, okay? So that's all the same. But then Clang provides us all of these different overloads, and it tells us where each of them is defined, and it says why it doesn't match, right? And so it'll say things, for example, like, this is not viable because there's no known conversion from this C array to unsigned int. And if there are a bunch of different parameters, then it'll just point out the ones that matter, right? And it'll say there's no conversion from this to that. There's no conversion from this to that. And what I want to do is I want to improve upon this. So this is a thing I'm not ready to show you yet, but I'm teasing right now. This is teasing. So just as Clojure gave us this, and I improved upon it to be this for jank, C++ gives us this, and I want to improve upon it following the same sort of pattern that we have here. But I want to provide some really nicely formatted output, and I want to provide a lot more information, not just for like where these files are, but like a lot of your headers in jank are going to be coming from packages, right? And so it'd be really great to know that, like, oh, this comes from the boostsys packages, the package that you have installed. That's a dependency of your project, version 0.1.18, you know, and also like the various parameters that are involved. How are they working? You know, maybe there are 5 parameters to a function. One of them is ultimately the problem, but you get to see that, like, okay, well, the first parameter, that's just a straight up match. The second parameter, there's an implicit conversion going on. The third parameter, there's a trait conversion going on. Fourth parameter, that's a good match. And then the fifth parameter, there's a problem with that one or something like that. So I have big plans for this, but the problem is getting all of this info from Clang and then putting it all together in a way that looks good and is viable is incredibly difficult. So I don't actually know of anyone who is rendering C++ errors in any other way. Like GCC and Clang basically do the same shit. Clang historically has looked nicer. Like Clang had colors. Can you believe that? Clang had colors. Back in my day, we did not have colors for C++ compiler errors. And GCC and Clang both have colors now. But I think, and I think GCC actually has pretty nice formatting and underlining of the parameters and everything like that now as well. But still, we're limited to just like this big old fucking dump. And the thing is, I know there are some reasons why we do this. And those who are familiar with this may jump in and say, oh, well, we do this for this particular reason. The main reason that things are in this format is that this format is understood by like text editor tooling and IDEs and whatnot, where you have a line that starts with a file name and then a colon and then a line and then a colon and then the character and then a colon and then the severity note or error, right, or warning, and then the actual message. And IDEs understand this and then they incorporate it into their tooling. So there's benefit to this. But when you're looking at it in a terminal, right, this is not designed for humans. This is designed for other programs to process. This is designed for computers to process. And I think that's all well and good. It's nice to have some sort of structured output that makes it easy for other tooling to read. But I also think that we should optimize for humans when we're looking at output. And what do humans do when we look at things, right? We lay things out visually, right? This thing is next to this thing. This thing is below this thing. There's so much more that we could be laying out to just make this stuff easier to grasp that we're just not doing. It's not even great for programmatic access. Yeah, I mean it's somewhere in between, I think, right? I think they're trying to strike the balance between like, yeah, you could parse this, and also like, yeah, you can follow this if you're a human, you know, you can sort of read through this. And so I can see why we ended up getting here. And this is more of what I want, right? So to start with, like, I want to optimize for the terminal-based approach. That's because I use jank from the terminal. Like I'm not using an IDE. I don't, integrate compiler errors into my IDE outside of like LSP. You know, LSP does that for me. And I want to build on this same sort of methodology with the C++ errors as well. And this is going to be, if I can pull off what I want, I think it's going to be a big deal. I'm just trying to think of like how I want to put it, but it's the sort of thing that I want to be able to show this to C++ devs and have them be like, damn, that is nice. And that could be a big selling point for jank, and just like bringing in C++ devs, C++, whatever native devs, into the Clojure world, because not only do we have Clojure and all the goodies of interactive development and easy package management and AOT compilation and everything like that, but also like error messages are really good. And then the follow-on question is like, well, would there be a data format that IDEs can use? I mean, I want to support other output formats, both for Clojure errors as well as C++ errors. I just don't know what it'll be yet. I think it makes sense to do something that's like JSON based. I just don't know if there are standards for this, or if this sort of format is just the standard. So I'm going to start with making things look as good as I want them to look. Because in order to do that, we need to have so much more information. And once we already have all that information, then laying it out more dumbly, either like this or like a JSON or whatever, I think should be should be straightforward. And then given a environment variable or a flag, then you get to choose which one you want. But yeah, we're going to default to jank having sexy error messages, because that's what I want. Hey, Rune. Hope you're doing great. Finally figured out that web component for now. About to include it in the admin page I'm building on Pedestal. What web component is that? So it's a wrapper over Sorto.js. Ah, cool. Nice job. I hope you're having a good day. Thanks for coming in and hanging out. So here we are, almost 30 minutes in. And all I've done is rant about the two things that I've been working on. And so, yeah, I am trying to figure out how to make these C++ error messages look good. And that's not only designing a nice output, but that's also like figuring out how to get all of this information from Clang. And I think there's like, it's easy enough to sort of dream up. Well, it's actually not that easy, but it's easier to dream up a design that's going to look good and cover all the different cases of C++. But then just being able to get all of that information from Clang in the first place is, I think, something that's just not been done before. So we'll see. That's still a big question mark. I don't know if it's going to be possible. I'm hoping. I'm gonna work hard for it. And then the other one is the runtime errors, right? So like being able to get a good stack trace, where I would like this to even just say like user/foo, you know, I know these are all C++ thingies, but I'd like it for the jank frames to not even show like the compiled jank function name, because otherwise it'd be like user_foo_77_0 is what it would look like, and that's not gonna map well when you're like, okay, I wrote a function called foo. I guess this has foo in the name, but what's the 77 and what's the 0? And that's actually like the monotonically increasing unique identifier, and then the arity that we generate those into the compiled symbols. So yeah, I think that there's more work to do on both of these, but a lot of it for both of them is just way too exploratory right now, and so I didn't want to jump into it. But I did want to tease it because it's the big thing I'm tackling now, and I'm going to be really excited to show this off. I'm really hoping that I have this all done, or at least in like a really nice state by the conch, so then I can show it all off. Okay. But what we're actually going to do today is something that's tangentially related to error messages, at least the runtime side of things, is that we're going to tackle, I don't know where it is, somewhere. Oh, right here. Yeah. So we're going to try to tackle these. I don't think we can get to this because I don't want to do this until we have a design that's going to... there's some discussion going on with the core team, core closure team, around like what would a cross-platform catch-all look like. And I don't want to make a design in Jank until we have that figured out, because I don't want to... I'd rather not have it and then add it once there's a design, then add our own design for this, and then break that design once we come up with something else. So right now there are like a couple of competing standards, And rather than like tossing my own into the hat, you know, I think I'll just wait. But we could do these two today for sure. And historically, over the past, I don't know, 4 streams at least, I've picked up something. I'm like, I think I can do this. And then I end the stream and I'm like pretty close, but like, turns out there's a bunch of shit that we run into along the way. And I have not actually been able to finish a stream like with like everything being done, in a while. I have done it in like older streams, but in the past month or so, that's not happened. So maybe we'll try to do these 2 today, and we'll see if we can get them both done. So the first one is being not if I keep chatting. Yeah, not if I keep chatting. The first one is being able to throw native values. And so right now, if you do this, so toString is going to give us, toString is we just give it an integer, is going to give us back a standard string. And so in C++, you should just be able to throw a standard string, no problem. But jank's throw type analysis is going to fail on that. Wait, do we support this already? Oh man, this stream's gonna go so well. Oh, no, it's because it's because strings are trait convertible. And so you can see here, this is the generated code, right? So we took 4, that's V1. We called standard toString on it. And then before we threw it, we did a trait conversion. So we did a jank runtime convert into object. So we took our standard string, we converted it into an object, and then we throw that. So if we were to take a value that was not trait convertible, like foo, yeah. So here we just have like unknown implicit conversion from foo to object ref. Now this is interesting because this ends up being an internal analysis failure, and we don't have source here. So this must mean that we don't actually have a test for trying to throw native stuff. Probably because we have a skipped test for it. Yeah, because I updated the test runner to make it so that whenever we run all those 850 plus jank files, that they either start with pass or fail to say, or actually pass, throw, or fail to say what we're expecting them to do. That if they are expected to fail, that their failure needs to have a source snippet with it. Like this does not have a source snippet, snore snippet. And so that would have been a failure on its own. Yeah, but we're not going to worry about that because we're going to fix this anyway. So that way we can actually just throw a foo. We should be able to throw a foo. So without further ado, let's do it. Oh shit. I don't have my music on. Let me get some music on. All right. Now we'll do it. So, first thing is, I don't think we're going to need to change probably anything in the IR or in CodeGen because we're just taking values and throwing them. But we need to change this in the analysis. And then we're going to need to write some tests for this. So we're just going to do analyze throw is going to be the function that we're in. And this is a very small function. Like this is it. We got 26 lines for the entire analysis of throw. And all we do is we verify we have enough arguments. We're actually going to change this later because that's the next one we're doing. Yeah, for rethrowing the current exception. Then we grab the first argument. We analyze it, so that's a recursive call. If we have an error, we return that. And then here we go. We apply an implicit conversion. And so basically we take whatever, so this analyze gives us back an AST expression. We take whatever AST expression we get back here, and we try to implicitly convert it to this untyped object ref. And so basically this will either do a trait conversion for us, or it'll do any other implicit conversion. Like for example, if we have a typed object, if we have a persistent string ref, this will give us back an implicit conversion to an object ref, which happens automatically through the C++ type system. So we just need to remove this. Deleting code is great. Okay, so we analyze our value, and then we throw our value. That's it. Do we need to do anything else? I don't think so. Let's try it. Just make sure I have, yeah, I have J16 on. Okay, so rather than getting this error, we get a code gen failure. So it still tells us what we were doing code gen for, which is great. But let's take a look at what the actual code gen failure is. Okay, so there are two errors. One is very interesting and the other one is less interesting. Let me work around the less interesting one right now. And then we can return to the interesting one later. So here's the less interesting one. We need to change code gen. So basically what we're doing now is we're analyzing this and we're saying, yep, that's fine. We can create a foo. We'll call it v1. And then we can throw that foo. But right now our throwing is hard coded for the code gen to cast whatever we're throwing to object ref. The reason that we do this is if we're throwing a typed object like a persistent string ref or persistent vector ref, we want to cast that. We want to cast that down or up. I never remember which one's upcasting and which one's downcasting because it's always opposite of what I actually remember it being. Because I think I always imagine that the bottom, because it's a tree, and so trees actually grow from the roots toward the sky. And so I always imagine that like the base object is at the bottom. And then if you want to upcast, you're going to a more derived thing. But I think it's actually the opposite of that. But anyway, we're trying to cast to, this is basically like in Java, we're taking some persistent string or persistent array map, and we're casting it to an object. So we're just type erasing it. And we do this because if you were to throw a persistent string ref versus throwing an object ref, that's a different thing. You can't throw a persistent string ref and then try to catch an object ref and just have all of that work. You could, if we were just throwing raw pointers, because persistent string inherits from object, but because we're using a smart pointer, which is what this underscore ref implies, it's a smart pointer that does a lot of work for us actually. Then we can't actually rely on the benefits of the polymorphic throwing catching. So we need to intentionally type erase. So we can't just unconditionally do this static cast now because we can't cast foo to an object ref. So what we need to do is so we just need to check. So here's the C++ code gen for our throw expression. We just need to check, rather than unconditionally doing a throw with a static cast, we need to only do that if we have an object. So what we can do is we can say is any object, and we have inst and value. I would really like to have the type of the value. Do we have that? Let me take a look at the IR that we have. So the throw has just type void. So I would need to look up the type of the value, or I would need to put it inside of the instruction. I think I'd rather put it inside of the instruction. So we'll do value type. That doesn't exist yet, but we'll put it here. So if we have an object, then we'll cast it, and otherwise we are going to just throw the value as it is. Okay. So now we need to go into where we're creating the IR for throw. We need to, so our throw expression has a AST node for the value. So we're going to be able to get the type from that. And we're passing in the value right here. Yeah. So that means that we can actually do expr value get type. Yeah, and then so IR builder, our IR builder for throw is going to take a type as well. And we'll put that here. And now we need to pass in the value, and we need to pass in the type. And that goes inside of the instruction. That's good. And then we need this guy to take a pointer void const type. And good. Oh, this needs to be value type. Because we already have a type member for this. Let me adjust the Twitch window so it's no longer in my way. Still a little in my way, but it works. Okay, now IR print throw. So we're gonna have value, and now we need to have value type. That's gonna be quoted value, and then all right, value type. And this is going to complain about raw string. Fine, you can do that. Yeah, we don't need to do anything here with rewriting or walking. I think that's it. All right. So now we try again. Nice. So terminate was called after throwing an instance of foo. And we can see our function here is just the creation of the foo and then the throwing of the foo. The fact that it does the line 3 twice here is a bug. Because it shouldn't actually be showing, it shouldn't be introducing these new line statements unless they're different from the previous line statement. But it's a known bug. Okay, so now we can throw native values. Is there anything else we need to worry about? I don't think so. I think we just got to test it. So let's jump to test CPP throw. Do we have a throw here? Nope, we have try. What do we have in here? Rethrow. Yeah, we're gonna do our own throw. I think we duplicate the line because the CVP lines will increment it. So they auto increment. This rings a bell. This rings a bell. So shout out DJ Blue, because he was the one who implemented all of this source stuff. There are, while we're on the topic though, DJ Blue, there are some issues with this. I think this one is not, because I think you're right that there's the auto incrementing, but there are issues that I've been seeing that where the source is not right. But I don't necessarily think that's your fault. I think that macro might have issues. Yeah, I think that there's some stuff with macros where I have a lot of functions that end up just having like closure core source information that, like it shouldn't have closure core source information, but probably it's because like let is a closure core macro, and then like everything in there ends up being affected. So I don't know what those issues are. The other thing is, I think that we probably want to do, because like we only do these source things right now inside of the function. But I think it makes sense to have one. And I was just, I don't know if you were here earlier, DJ Blue, but I was just talking about how I'm trying to tackle the error reporting improvements. Two things. One is getting symbolicated stack traces, including just-in-time compiled frames that have line and source, line and file information as well. And I think that in order to have that, we need to have at least one like line pragma before the definition of the function that says that this function belongs to this, particular line as well. So like I hacked that in the test that I've been doing, and that allowed it to work. I think having them just on the inside doesn't yet grant us that. But yeah, I mean, it gets us very nearly there. Oh man, that error reporting stuff's going to be super cool. It's going to be gorgeous. Okay, so we need to throw native value. I really don't know if there's anything more we need to worry about. So I'm just going to get the obvious one out of the way. And so we're going to have I think this is jank cpp throw. So we'll have a struct foo in here. Do we want, yeah, let's put something in here. So we'll do a no, we won't do a number there. And then in here, we'll create, how do we want to do this? Let's do a try. Let's do a throw, jank cpp throw, foo 5. We'll do a catch of jank cpp throw foo. F, and then we'll say if A, then success. And to start with, I'm going to put a print line right here, and that should be our test. Nice. So just to catch everyone up, so we define our own struct, and we give it an integer. This is just default initialized. We put it in a custom namespace because we call everything foo, and we have several hundred of these tests. So each one just gets its own namespace. And then our actual test here is we throw an instance of one of these guys, and then we catch it, and we verify that the value of A is still 5. And so basically we're checking here that not only did we catch something that was, the correct type, but also it has the correct value as well. The way that our test runner works is that successful tests need to evaluate to the success keyword. And so ideally we try to conditionally evaluate to success keyword rather than just like putting success at the end and being like, oh, we're done. Yeah, it works. I used to do that. And then I ran into a bunch of cases where like it didn't quite work. It didn't fail, it didn't throw, but it didn't quite work. And we still considered it successful. And so instead we'll try to like be a bit more defensive. That's a lesson learned there. So this here, we're throwing this value that's actually created as part of the throw expression. I wonder if it makes sense now to also try to throw a value from the stack. let's do this in, so where were we? In C++, we just had this thing. So let's say we have a type here, and let's say that type is not copyable and not movable. And then let's say I do a try catch foo, and I throw, let's say I have a foo, and then I throw f. So this will be a failure. Yeah, so this is an interesting case. Empty catch statements hide issues. Yeah, well, so does your passive aggressive tone, Mr. Compiler. Okay, this is a good one. I like this one. So this code will fail. Or this code will fail in C++, it needs to fail in jank as well. And the way that it works is we have a stack allocated foo object, and we're using the default constructor here. But when you throw, you can't just throw this value, because this value's, it lives on the stack. And when you throw, the whole point of throwing is to unwind the stack. And so that means that the stuff that's on the stack can't be referenced anymore, because those stack frames aren't going to exist. A very, in my opinion, interesting tangent on this is C++ uses exceptions to convey all sorts of things. And that includes things like out of memory errors, right? And so if you try to allocate some memory with new and you don't get, you can't do that allocation, an exception is thrown. But we've already just discussed how you can't throw a value that is on the stack, which implies that you need to allocate space for that value somewhere else. And that's exactly what happens. But if you're out of memory because you just tried to do a new, then how do you actually allocate memory somewhere else in order to be able to throw the exception? How do you do it? So this is actually handled by the C++ runtime, where C++ does have a runtime, but unlike the JVM or something like that, it is much more minimal, right? It's much smaller. But the C++ runtime does allocate space on the side for this sort of scenario where an exception has basically been pre-allocated, enough space to hold an out-of-memory exception. And so we're able to just grab that memory and use that. That was the small tangent that I thought was interesting, which is the C++ runtime pre-allocates memory so that we can still dynamically allocate out-of-memory exceptions when we're out of memory. But this particular one, what we're going to need to do is basically when we do a throw, we're going to need to dynamically allocate some memory, enough to hold the foo object. And then we're going to need to call the copy constructor to initialize a foo object at that memory address, and we'll copy our f into that new foo. But foo here has a deleted copy constructor, so we're specifically saying you cannot do this. You cannot copy. You cannot move. And if we try to compile this, then we just get a call to deleted constructor. And so this is also I had in my notes here for like invalid call deleted, right? because I'm jumping back to, I'm jumping all over the place here. Can't keep up. When I was talking about the C++ error messages, right? The sort of thing that we want to do in jank, we want to point it like, okay, this is the throw where you're trying to do this thing, but we can't call the deleted constructor a foo. And then we want to point at that particular constructor and say, oh, well, we can't do that here. Now, interestingly, this is actually trying to use the move constructor. Foo.cpp. Let me get this open here. That makes sense. It's going to try to move. It makes a lot of sense, actually. It's going to try to move F rather than copy it. Why? Why would it move instead of copy? The answer is that, as we discussed, the stack is going to unwind. So there's no point keeping F alive because as soon as we unwind the stack, its destructor is going to be called and it's gone. It's donezo. So we might as well try to move from it. So that's why we don't even need to worry about this guy. We just need to worry about the move constructor. Although I do wonder if you don't have the move, but you have a copy constructor, does that work? No. Yes, actually. No. So this is deleted. This works. Now, which of these is it actually doing? Let's drop this into Godbolt and then take a look. So Godbolt, is it time for Idris 2 yet? I don't know. This is not the right Godbolt. .org, I think. All right, so Godbolt has some incredibly cool functionality. You can take a look at, like, by default, you're just going to get the assembly. But what we're going to do is we're going to drop this guy to Clang x86-64. And I'm going to scroll past this section. I'm going to get to here. And then we're going to add a new output. Nope. We're going to add new LOVM-IR, no, AST. So yeah, they have LOVM-IR there. Wait, why did that? Where did that other one go? Why is this showing the whole thing? I dragged it to a tab. Huh. That's blowing my mind. Tab. It tabs there. Doesn't tab here. Okay, fine. Well, we'll look at it over here in this tab. So, actually, you know what? I'm gonna compiler. Try this again. All right, give me this over here. Yeah, there we go. Yeah, because I want to be able to see the code and the AST at the same time. So let's take a look at this throw right here. Now, the lovely thing is the source information tells you what part of the AST you're looking at when you mouse over different lines as well. Isn't that lovely? So we want to look at the throw here. And so we have this CSX throw expression. And then we have a CXX construct expression, implicit cast expression, and then you have this decal ref expression. So we can actually see here that this is going to use the copy constructor. Nice. I love that. Oh, big raid coming in. We got to wait for them to get through the intro ads. Hey, Maya. That's a very kind raid. I appreciate you. I hope that you had a lovely stream today. I know I get raiders don't get pre-rolls? Oh, that's lovely. Thanks Boner Pull for telling me that. I thought they do. Do they? Now you're questioning yourself. It was great. Thank you. How are you? I'm doing great. We're having a good time looking into some C++ ASTs that are generated by Clang to figure out what's happening when we're throwing C++ values so we can replicate it in our compiler. So it's that's our impression of a good time. Let me drop you a follow there. I know Maya that I get super exhausted at the end of my stream. So if you feel like you need to raid and run, you're most welcome to. But I do appreciate that raid. I appreciate you. And I appreciate the sub. What a day. Thanks, Boner Pole. So we're working on the jank compiler, and jank is a dialect of Clojure. Clojure is a Lisp programming language, and jank is a native dialect of Clojure that runs on instead of running on the JVM, which is where Clojure normally is, it runs on the native world. And we have seamless C++ interop, which is pretty badass. If we take a look at the website, I'll show you an example. So I'll answer that question in just a second, Maya. This is some example jank code, but you'll notice that we're including a straight up C++ header file right in the middle of it. And then we're grabbing some, this is a C++ overloaded function, and we're just renaming that to be something else. And then we call that later on right here. And when we call that here, that's when we do the actual overload resolution. And so we're kind of switching between dynamically typed Clojure code. So this def in here is here's a Clojure function. This is all dynamically typed. And then the actual statically typed C++ side of things, which is, when we call file size and we take our dynamically typed file path parameter and we cast that to a standard string. And then what we get back from that is this is a straight up C++ value that's stack allocated as well. And then we're throwing and catching C++ exceptions. And so we just sort of weave right in between dynamically typed functional programming in Clojure and statically typed whatever programming in C++. That's what jank is. And so we're trying to make this whole thing viable. Yeah, we got the whole website and all. I've been working on jank full time for over a year and a half now, and then much longer than that before I was full time. It's something I'm pretty serious about. But yeah, I just wanted to take Clojure and C++ and combine them. Does the website have a light theme? You bet. Let me show you. Open up the old trusty dev tools and click on this guy, and there's our light theme. The code bits are still dark. I don't know if, and then we kind of alternate between light and dark. The light theme still has dark stuff in it, but it is lighter. I do like the darker stuff though, I will admit. Even when I'm just browsing normal stuff, I have Dark Reader plugin to make websites dark. You know that Lego Batman, first Lego Batman? No, was it? It's just a Lego movie where there's Batman, and then he's like, "Darkness, no parents," and then that's his song. That's kind of like me in my browser. Meanwhile, Discord light theme, I don't even know what that looks like. I have literally never seen Discord with a light theme. Oh my. Ouch. How do your eyes work? It's too bright for me. It's too much. Yeah. I can't. You guys are crazy. So we're actually throwing a copy here. So that means we need to deal with no copy and no move constructors. What was it, Maya? What was it that you guys were tackling on your stream? I'm clicking out. Oh, there we go. Wait, no, man. Hold on. I'm bad. I'm quite bad at Twitch. Oh, there we go. Oh, you're working. No. You're working on the Game Boy. Yeah. I saw you. You're working on the Game Boy Advance emulator. Nice. Those. I got to catch up on that. I have worked on. I won't say I made. I worked on one of those. It's a sort of thing where it ends up being a lot more work than you realize. It was a lot more work than I realized. I tried doing that in Clojure. I think Rust is a lot better fit for it than Clojure. Is a lot, but learning a lot. Yeah. The Game Boy hardware. I mean, GBA is a lot more advanced. It's in the name. It's in the namesake. But even those, like they're quite well documented, which is good. But there's still regardless of how well documented there are, it's still a lot of draw the rest of the owl type thing, you know? Yeah, especially if you want to be precisely implemented. Yeah, okay, I'll check that out. All my normal jankers, check out what Maya's doing as well. Okay, let me jump back into this. So we have our example here. We just made it so we could throw native values. I'm going to set that interesting error aside right now because I don't want to deal with it. But this is some actual jank code where we have some inline C++ where it's just like raw dogging C++ literal right inside of the jank file. And then we're defining a function and then immediately calling that function. And that function is throwing an instance of this foo. And so here we're reaching into the C++ world with the cpp/ to grab a foo and create an instance of it, and then we're throwing that. And so we're trying to come up with some tests for this. And we have this guy, but now we're going to do another one where we don't have one way to do FFI. Well, yeah, that's the thing about jank is that normally when people do FFI, first off, you have to just go through a C ABI. Whereas like we're actually dealing with C++. And so when jank allows you to just-in-time compile C++, that's kind of like the moment for a lot of people when they're thinking about jank is like this CPP raw here, for example, like you can evaluate this at runtime. This is just the way that we code things in Clojure, is that like you'll start up your program. Let's say you're making a game in Clojure. You'll start up your program and then you can just like send new code to your running program. And so jank supports this. And so you can send just-in-time compiled C++ code into your running program, and it'll just be like, right? And then, like that's how we roll. But we also support AOT compiling as well. And so that means that you can do, rather than just going through the C ABI, like you can just include a C++ header file. We'll JIT compile all of that C++ in the header file, and then the whole runtime will know everything that was described in that header. So it's a lot more seamless than trying to do like a C API, where you're just like, okay, let me wrap some functions around this. Like you can actually work with templates and constructors and destructors and everything like that. Let me make a new one of these guys. And so I'm going to do a tab. So I'm going to do no copy ctor. No copy ctor. Oh, right. I should have named this pass native value. And so this was pass native value, and this was pass native value. Yeah, and so native value becomes, wait, the same thing. No copy ctor and value. No copy ctor and then no copy ctor. Okay, so inside of here, what we're going to do is we're going to yoink all of that. What did we have? Where did we have it? Oh, we had it here. I don't want to yoink from there. So we'll have a default constructor. Let's say, no, we want a constructor that takes an int. So let's say we won't have a default constructor. We'll have a default constructor that takes an int, and we'll initialize a to I. And now we won't have a default constructor. Delete. And then we won't have a copy constructor, foo. But we will have a move constructor. Okay, that should set us up for everything that we need. So we can construct a foo, and then I'm gonna put this into a let here. So we'll actually have a local for this. Move needed for the throat. Love that question. So that's what we were actually just looking at here in Godbolt, which is a compiler explorer. And we found that the compiler will generate a move for us. And I think the reasoning here is that the stack frame is going to be unwound anyway. And so if you're going to be throwing a local value, I think it's just the compiler is just going to automatically move that value, which makes sense. So we should get an automatic move of this value for us. let's take a look. So we have a local F. That's a foo created with 5. We throw that F. We should get our move constructor, and then we should be able to catch that, and then a should be equal to 5, and then we're good. Let me add a print line here so we can verify, and then we'll do a jank run, pass native value, no copy, ctor. Perfect. So that works. So now let's do the same exact thing. And then we'll do a no move. So now we're going to have a copy constructor, but we're not going to have a move constructor. And so this is the same sort of thing where it can't select the move, but does it select the copy? And I think we have to disable this. I don't think we can explicitly delete that, but I don't understand why yet, because so this worked if we have the move constructor commented out, but we have the copy constructor defaulted, then this worked. And when we take a look at the throw expression right here, CXX throw expression, we can see here that we're the value or the expression that we're throwing is the CXX construct expression, and that's the move constructor right here. I'm sorry, that's the copy constructor right here. So it is selecting the copy constructor, but if we bring this in and we delete this, okay, so this does, no, we have a compiler here. We have a compiler error here, I mean. If we take a look at this, yeah, compilation failed, output. Yeah, so it's very odd to me that here, when we have this, this works and it selects the copy constructor. And it's going to use the copy constructor anyway, because the move constructor is implicitly deleted here because we have already explicitly defaulted or deleted some of these constructors. That means that anything that we haven't explicitly specified is already implicitly deleted, if that makes sense. But that's how it works. So the move constructor is already implicitly deleted. But if we explicitly delete it, then the whole thing breaks. I think that's kind of lame, but it's C++. So, yeah. But we, in terms of our compiler, we should have a test where we actually have this case, because we want to behave the same way that C++ does. And so we're going to need to test like, well, okay, we're not going to be able to throw in that case either. So there are two cases, I think, where we're not going to be able to throw. One is where we don't have copy constructor and we don't have a move constructor both at the same time. That's one. And the other one is where we have a copy constructor and we have an explicitly disabled move constructor because C++ doesn't allow that either. But for this one, we'll have that commented out. So this should work. Let me wrap this in a print line. And we'll do a jank run, pass, no move. Perfect. So there's our no, yep, perfect. And now that's it for our passes. So now we can jump to fail. So we'll have a no, we'll have a deleted move constructor. And that's going to be the same exact thing, except this guy right here is enabled. That's it. So I'm going to remove that from here. And then the other one that we have is, also no deleted. Okay. Now the other one that we want is, oh damn, I did delete in the name as well. Gonna have to rename that. I made the same mistake when I was typing the namespace name. So this one is no copy CTOR, no move CTOR. I guess I should say deleted, to be consistent. Deleted, copy CTOR, deleted, move CTOR. Oh, I probably don't want to do that. Deleted, copy CTOR, deleted, move CTOR, foo. Okay, so this one we are expecting to fail. This one should be delete. So we have no copy, we have no move. All right, so jank run, fail. So delete. All right, I need to rename that. There we go. Fail, native, deleted, move. Okay. This does fail, but it fails in the wrong spot. And this is because we're going to fail during code gen, because we try to generate the C++ code for this, and then obviously that C++ code doesn't compile. But we need to catch this sooner. We need to actually catch this in analysis, because we need to actually prevent this from even reaching code gen. This one as well, same thing. We're going to fail it when we actually try to compile the C++ code, but we are not failing it sooner. We need to fail that sooner. So for all of you who came in with Maya, jank compiles to C++. And that's for very good reason. All of the C++ interop that we have, since C++ doesn't have like a standard ABI, if you want to do C++ interop, you need a C++ compiler. So we tried to do C++ interop just with LLVMIR, so where jank just compiles to LLVMIR, and then we do all of our interop stuff of accessing members and calling virtual functions and destructors and throwing and catching and everything like that with LLVMIR, and it was just thousands upon thousands of lines of like IR generation that was basically just reproducing like big portions of Clang. and it's a mess, and it changes over time, and it's so much work that is not actually related to what we're doing, creating the language that's built on top of C++, because it's basically just re-implementing a C++ compiler. So ultimately we decided that it just makes sense to generate C++. That's really nice in some ways, because it means that you can take an entire jank project with all of your jank files and all of your dependencies and everything like that. Jank has a build system that's modeled after Cargo, so it'll be familiar to you Rust folks. And so you pull in all your dependencies, and we have jank build scripts that are modeled after Rust build scripts as well. And so the nice thing about being able to generate C++ is that you can take that entire project of all of your jank files and all of your dependencies and their jank files, and you can just compile them down to C++ files. And at that point, you just have a C++ project, right? And so then you can plug that into any existing C++ build system. And that includes things like the Zig Zig C++ build system that allows you to then really easily get portable builds for like cross compiling or targeting old glibc and everything like that. That's a really big win. But the biggest downside is, well, when we're generating C++ code from jank code, it means that we need to pay the compile time cost of C++. And of course, that's pretty high. C++ is not fast to compile. And so we just do our best to generate the smallest, most minimal C++ code that we can. And then, so yeah, let's say, I'll show you an example. Like if we take something like this, so this is all straight up C++ code. So there's, that's copied in wholesale. But if we have something like this try with a let that creates a foo and then throws the foo and then catches the foo and then checks if the foo is equal to 5, we can see what we generated if I can type it. So this is the code that's generated in this case, and we have this like straight up C++ function. So we have our try, we have our catch. Our try is creating this foo, throwing it, and then our catch has to do actually quite a bit of work. Because in order to grab out the A and then compare it to 5, like this equals function is actually a closure function that accepts boxed closure objects. And so we need to actually like box these objects. And there's a lot of like implicit work going on when we mix the native world and the closure world. And so that explains the bulk of what's going on in here. Okay, so we need to jump into the analysis and see what we can do about the throwing. So yeah, so back in the analyze throw function, we analyze our value and we get back this AST expression. Now we need to check the type of the value. We need to see if it's copy constructible or move constructible. It has to be one or the other. And then we'll also have to check if it's copy constructible, but it has a move constructor that's deleted, because that was that other case that we found. Yeah, and I don't like that behavior, but it is what closure. It's what C++ does. And so even if we wanted to allow that, we couldn't, because since we're generating C++, we could allow it, but then we generate the C++ for it, and then Clang won't compile that. So the first one is the easiest one. Let's just make sure that the type that we have is copyable or move constructible. So we want auto const arg type. So that's going to be our arg expr, expect OK, and then get type. And then we're going to want to check. So we're going to want to scope from this. So we're working with Clang AST types here because Jank just integrates directly into the Clang AST. That's how we do all of our C++ interop, is that we're just latching we're just latching onto Clang like some sort of urchin. We probably want a just want to see if we have any sort of helpers for this already. So we have is constructible. Nope. Let me check the Yeah, we don't have anything here for... We have has default constructor. Get default constructor, look up constructors. Is constructor, is explicit. And that's it. Okay, so I think we're gonna wanna go to has default constructor. That just actually has a member for, look up default constructor. Did this project start as post EA therapy? Respectfully. Oh man. No, I was already working on this at EA. I've been working, I started Jank like 10 years ago as a research project for like what I want my ideal language to be, because I was just hitting limits with C++. And then it's only about the past 3 years. Like I did a whole bunch of different iterations of Jank. But laughter was the response you wanted. Glad it came across. Yeah. You know, honestly, like EA gets a lot of shit. They do. And I will give EA shit on the right day as well. I was just giving EA shit to some other friends recently, like Andrew Wilson, the CEO of EA, was just announced to have like I think it's like a 305-to-1 ratio, compensation ratio to the median EA employee. And amidst all of the recent layoffs for the successful launch of one of their games, he got an $8 million raise. You know, like there are some serious problems with the way that EA is run and the way that wealth is distributed in EA. With that said, though, EA was actually the best place I've ever worked. And that's not because I've worked in a lot of really bad places. It's because EA is a huge company, and depending on the organization that you're in and the people that are running those organizations, it can be really good. It can be really good. And so I worked in an org that was run by somebody that I had worked with before, like a decade prior. And when I was done with my startup, he was like, yeah, why don't you come to EA? And I did. And it was great. Like the culture that he set, the way that everybody worked with each other, respected each other, treated each other, was superb. The pay was superb. And the benefits were superb. The training that they had, like the manager training, just the cultural training of like how they're trying to teach everyone how to treat each other and talk to each other was amazing. Like I liked a lot of it. And on top of that, while I was at EA, now it does help that the person who brought me in was the one who was running the org, and he was able to hit pretty hard in my favor. But I was able to negotiate a contract where I switched from full time to working just 3 days a week, and I kept my benefits. The only thing was, like, since I wasn't working 40% of the time, I gave up 40% of my income, and my stock vested 40% slower. That was it. I kept all my other benefits. It was a fucking amazing deal. So I worked Monday, Tuesday, Wednesday, and then Thursday through Sunday I was working on Jank. And so it was because of that I was able to do that for like 2 years, I think. That allowed me to like really ramp up on working on jank before I finally left EA and to focus on jank full time. So yeah, it's mixed. Microsoft was like that. You can work at one of 1,000 different places within Microsoft. Guy across the building could be having a completely different experience. Yeah, for sure. Yeah. So it's easy to shit on the big companies, and there's a lot of reason to, but I can definitely see why people enjoy it as well. I certainly did. With that said, I was working on back-end tech in EA, and I don't ever want to do that again. I somehow found myself working, like I started in game dev and somehow found myself working in back-end tech. Not even back-end tech, just web tech in general. Like I was building SPAs, but I was also like dealing with back. I don't even want to talk about back-end stuff. I'm like, as soon as I have to say Kubernetes and fucking Terraform, and I'm just like, no, I don't want to get into this. I was so happy to get back into compilers or like back into local development. Let's see. So we're looking at Klang's code, case trauma. Yeah. Yeah, I really don't like the direction this was several years ago already, but I didn't like the direction that the industry was going with making everything microservices when they really don't need to be. Like, and the way that we interview people for back-end roles as well as, okay, let's say you're architecting the Slack style, chat service, and you're going to have many to one relationship of, users to channels. And, you also like are going to have, DMs, and how are you going to scale this? And then people are like, oh, well, what sort of load? And like, well, let's assume it's going to be millions of, messages a day. And so they were, oh, you're certainly going to need some replication here, and you're going to need a caching layer here, and then you're going to need to put this behind a load balancer, and database layouts and sharding, and then like meanwhile, our service that we built at EA had like 12 requests a day. Because it was an internal tool that was used by the game teams, and most days it was like maybe it went up to like 100 or something, 100 requests on a busy day. but at the same time they're like, oh yeah, we need to have replication. We need to have 3 of these running at the same time always. And I'm like, okay, sure. Yeah. Hacker News can run, it can be written in Lisp and just run on a single machine. But yeah, we definitely need this service, running on AWS in Kubernetes, to be self-healing with minimum replication factor of 3 and auto scaling. Definitely. Yeah, there is some KH trauma there. You're right, Bonerpool. Let's see. So we have default constructor. There's a fucking bit set here for declared special members. Has copy assignment. Okay. Has simple move constructor. Has simple copy constructor. That is not deleted. Unambiguous copy constructor that is not deleted. Unambiguous move constructor that is not deleted. Pretty sure it's running on a Raspberry Pi. I don't think so. But it is running on a single server. And it's written in Racket or some like scheme. Default destructor is deleted. Default move constructor is deleted. This is good stuff. This is what I want right here. Default copy constructor is deleted. Okay. So we need to expose these. So let me yoink these. So this library that we're in right here is a hell of a fork of a library that wraps Clay's, I'm gonna say API, but it's not a public API. It's just Clay's code, Clay's AST, and tries to make it a bit more user friendly. And then we forked the hell out of it, and we're like a couple hundred commits away at this point. And I tried to get it upstreamed, and then it didn't work. So I think it's probably never going to happen now. But like I have everything I want. The only benefit of upstreaming is that they handle the upgrades from one LLVM version to the next. But I don't mind doing it. And I don't want to have to deal with, like, I tried to work with them on it. And I even offered to pay them, to like add the tests that they want and everything. I was like, here's the code. It didn't pass the test suite that they had anymore. And I was like, hey, I'll pay you some money if you want to like get like one of your students to, or interns or whatever to work on this. And I think they weren't able to make that happen. So here we are, but it's open source. And so my fork is still up there, and if they want it, then they can get it. So what we want to check if we have has a defaulted copy constructor. And so we're going to do, is this going to give, yeah. Has default, has copy, has simple. Ooh, simple copy constructor or trivial copy constructor. Trivial copy constructor. It's simply trivial. Simple Ricks. So trivial copy constructor is different. A trivial copy constructor is not explicitly defaulted. A trivial copy constructor is like not even written. So we can, this is class copy P6. So if we jump into, does this have a search? This does not have a search anywhere. Where did that go? No, I wasn't there. I was over here. Class.copy. Yeah, I don't actually know if we can get to this without searching. This works. This is someone else's. 6. What do we have here? I think you just watched that episode of Rick and Morty. Man, you're far behind then, DJ Blue. Unless you rewatched it. I think that's an old one. Actually, the newest season of Rick and Morty was really, really good. I think it was kind of falling off after a while, but this last one was like surprisingly good. One quick aside, after the microservices hype started to wane, Austin used to live in Seattle. Oh, cool. I'm in Seattle. Worked at this place. They brought in BFF backends for front ends. I thought about it for 30 minutes and I'm like, we're not disciplined enough for this. You got to get the mobile team cramming features into the mobile BFF. Yeah. Yeah, I've seen this BFF trend as well. Yeah. Yeah, really, just honestly, happy to be out of web development. Do we have trivial? This isn't trivial. So copy move. Yeah, it's trivial if it's not user provided. That's what I said. Class has no virtual functions, no blah, 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 blah. Yeah, we don't really care about that. I think we just care about simple, but simple is not defined here. Simple is probably defined. Actually, maybe simple is not even defined in the standard. Simple could just be Clang terminology. But yeah, I think simple is all we care about. And so has simple copy constructor is good. And then what we're going to do is I'm gonna forward that terminology onward, and then we'll say has deleted copy constructor, and then defaulted copy constructor is deleted. That's the one. Cool. And then we're just going to repeat that same thing, except we're going to replace copy with move. Okay. So this goes after has defaulted constructor. My opinion, web dev can be great if you can ignore the industry and just do what makes sense for your problems. I guess that can be said for a lot of things. That's a fair point. Also, I'm reminded DJ Blue, and I don't mind. I hope this doesn't make you awkward, feel awkward. But it's too late now, and I'm going for it. I was worrying the other day that I upset you with something I said in chat, where I was saying how I was trying to convey how I really appreciate how you come up with these out of the box ideas and designs for things. And I feel like I have a kind of like C++ brain, where I'm like the obvious things to me are like they're going to work, but they're not always necessarily the best solution. They're just kind of like the J style, solution. And there have been a few times where you've come up with things where I'm like, what? And then I think about it and I'm like, oh, well, that's pretty clever. And I was trying to convey that. But I didn't know if it came across as like a backhanded compliment or something where I'm like, yeah, you often come up with things I don't understand, or that don't make sense to me. But what I was really trying to say is like, I like working with you, DJ Blue, because you because you come up with things that I wouldn't normally come up with, and they don't always pan out. But when they do, they're really great. Like the facade that we're using for the object ref wrapper, right, is like paying fucking dividends. That design is really, really working out, and that was all you. So I was trying to say that. I don't know if I said that. Not upset at all. Wanted to send the Pepe Sylvia meme. I'm not young enough to know what that meme is. I'm sorry. Maybe I'm no. Maybe it's not age. Maybe it's I'm just too. I'm just not on social media enough to know what that meme is. That name sounds familiar though. Pepe Sylvia. Oh wait, is that an Always Sunny thing? Or is that the frog thing? It's Always Sunny? Okay. In that case, I am old enough to know what that is. But I haven't made it. So I didn't start watching Always Sunny until this year. And so my wife and I had both never seen it. And we're working through it. I think we're on like season 3 or 4. But there are like a lot of seasons. there are a lot of seasons, and so we're slowly getting through it. I think we're not there yet. Yeah, it's so long. Yeah, but isn't the this is where I feel old. This is where the Zoomers call me a boomer. Is that like isn't the like the frog meme thing that all the kids do like named Pepe as well? Is that why I conflate the two? Like the Sag one, different Pepe. Yeah, that one. Isn't that a Twitch thing? I don't know, man. I see that all over the fucking place. I see that on Discord too. Okay, so we have all of these. Do these compile? Question mark. Nice. Compiling. Okay, cool. So that means I should just be able to then is the only Twitch stream I watch for the drama updates. I think it is hilarious that anybody would come to my stream for drama. I'm the least dramatic person I know. I'm like, there's some zig hate going on. I'm like, yeah, people are confused. What did we just call those? So yeah, has simple copy constructor. Oh, is that the one, Boner Poll? Is that the one from the mailroom? Because didn't Charlie also have some fucking red strings in the mailroom when he was working down there? I'm not dramatic. The most dramatic person you know. Damn. coming real deep, Shrek. Coming real deep. Whenever I talk to my family, and my sister and my mom or whatever, they just always have like, oh, and then this person like threw, you know, like some fucking dirty rag at this person, and then like it's, you know, it's like reality TV show, and I'm just like, what? How do you guys live like this? And then it makes me feel very non-traumatic. So maybe it's all relative. I don't know. But the thing is, like, when the thing is that when I found that on stream, drama sells, right? And tits, obviously, but I don't have tits. So, but drama really sells. And so people, they just want to hear people talk about things. And I think the most popular Twitch channels I've seen are the ones where they're just like covering daily news and politics, and they got tens of thousands of people watching, and they're all just like shitting on some current events. And it's the same thing like other coding streamers like Janet Carr, for example. She said before how, man, my nose is fucking itchy. She says before how like her most popular streams are the ones where she's not coding, and instead she has code open, and then she's just talking. And I've had that same exact experience. And that, I think it's just because it's harder to follow. It's harder to follow, you know, someone when they're just way in the code, writing it all down. Instead, the code is the room, and then we all kind of exist within it, and then and then talk in it. You won't believe what Jank did next. His Gen AI. Oh man. Kyle, will you do my like my Twitch titles? Cuz I would be a much bigger streamer, I think, if we did that. Oh man. Your guilty pleasure on Twitch is this guy this guy that lives is this guy that guys live whenever there's a car chase in California. Oh. Yeah, I mean, that's straight up watching Cops, right? Bad boys, bad boys. My opinion, learn a lot about weird shit about C++. Well, sure. I mean, like, yeah, I think most people are not very interested in the tangential, like, C++ bits where I'm like, oh, did you know that the C++ runtime pre-allocates memory, so that way when you're out of memory, you can still allocate the fucking out of memory exception? Like, most people are like, okay, nerd. Yeah, I recognize that's a pretty small audience I'm appealing to there. One of these times I'm going to remember the name of this function. So has simple, why don't I just copy it? And then we don't need to worry about that. Archetype. Okay, so if it has a simple copy constructor, or it has a simple move constructor. Oh, no, we're checking for an error here. So if it doesn't have, and it doesn't have, this is a dumb error. Okay, so let's just say invalid throw. And whoops. So unable to throw value of type blah, since it is neither copy construct. I'm off screen here. I can't actually see. Constructible. I'm typing in a Twitch chat. Constructible nor move constructible. And then that is a format string. And our format is the CPP util get qualified type name arg type word. Now, I only have one question here. Fuck. Yeah, so this takes in a scope, not a type. And so we'll need to get a scope. Arg scope. And so we're going to need to do a CPP util scope, get scope. Nope. CPP get scope from type, arg type. So it's possible this whole scope and type shit is the wrapper around the Clang API, and a scope is a Clang decal. But not all types can actually be scopes. And so like an int something, like a pointer, can't actually be a scope. And so we're going to get back a null pointer in that case. So we're going to have to check if arg scope and then we're going to need to update these to scope. Yeah, and if we don't have an arg scope, then we're just going to assume that that is fine because it's a primitive type, and so it's not going to have a deleted whatever. Okay. And then meta source. And then that. Okay. Save. All right. Nice. So yeah, now when we try to run this guy that has the deleted copy constructor, deleted move constructor, we get a nice error. Unable to throw a value of a type this foo, since it is neither copy constructible nor move constructible. I love that. So we don't get a code gen error there anymore. Now, the other one, deleted fail native deleted move constructor, just the move constructor. Yeah, so we get the same error, but it's not actually correct. You only have 80 columns on my terminal. Well, that's fine. So this would just wrap the I'm not yet sure. So I recently rewrote the whole output of this to remove FTX UI. And that's because Kyle, who's in chat, found that there's an issue with us using FTX UI, and also combined with the fact that I just really didn't like using FTX UI for this. And so I had planned to remove it anyway. So I've done that and it's gone, but it all looks the same. But now we're actually just using a string builder to build all this together. The main thing that we lost is the word wrapping that we had that was happening at this line as well. I'm torn as to whether or not I actually want that. So we do limit the lines. Like if you have a shorter terminal, then we won't draw like these lines beyond the width of the terminal. But I also don't actually like the look of drawing the line all the way across a really wide terminal. I don't know why. I just don't like it. And so I cap the limit of this to like, I don't know, 100 characters or something like that. And I'm still deciding whether or not I want to add in my own wrapping at that same width as well. In this case, because I actually have my Twitch chat open right in that, right here, it's really nice. It would be really nice to have that wrapping so I could actually read the error message. But in general, I think I would probably just let it flow. So this is not quite right now. We need to sort that out. So if here, I'm actually surprised that fails. That's nice. Yeah, see, but this fails. Hey, Groove Punk, welcome. Hope you're doing great. So in this case, we're throwing a foo, and foo, so this is no copy constructor. Yeah, I want to just show that here, I think. Yeah, so that's exactly why I ultimately decided, Bonerpool, to not do the lines all the way to the end for a wide terminal as well. Is it like, for me, especially in a tiling window manager such as this, if I were to then decide to split this, if I've done lines all the way to the side, like already we're seeing these lines wrap, and that's not ideal. But at least it's less, you know, it's less fucked up than it would be if I had lines going all the way across. And so you can't win when it comes to terminals, because like whatever you output, you're just kind of stuck with, you know, unless you're in like an interactive rendering application, which I have actually considered for the errors. Like, when you get dropped into a compiler error, you're actually like in an interactive window, and then that window, that would be super cool. And I'm still toying with the idea, because imagine you get dropped into an interactive window that still has access to like all the values, right? And so then you can just hop over F and then like do like a repo eval or something and get the value of F and like start toying with things and whatnot. But you're doing it from the terminal. Yeah, not important enough to toy with though when I'm actually trying to get a language shipped. But interesting. Right, so here we do have a defaulted move, but this says we don't have a simple move. And so clearly, whether or not we have a simple move is not actually what we thought it was. Has simple move constructor. Nightmare mode on a TUI. Busy data. All right. User declared copy constructor. So we have user declared copy constructor, and then we have simple copy constructor, and then we have trivial copy constructor. So simple copy constructor says has user declared copy. Oh, okay. And defaulted copy constructor is not deleted. I see. So that's what simple is that it's not user declared and it's not deleted. So what I actually want is I want to check, does it either have a simple copy constructor or does it have a user copy constructor that is not deleted? User declared copy constructor. Because I don't like, I'm fine with either. I don't actually need one or the other. So I need to actually do more than this. I need to say, this is move. Let's do this. So I want or, and then I'm going to do an and in here. User declared copy constructor and then is this public? Maybe. I'm gonna guess that this is not public. Yeah, it's fucking private. Is this available somewhere else? Oh, that's what this checks. Okay, so if it has a simple copy constructor or it has a user declared copy constructor and that is not deleted, that's what we want. And then same thing here, but copy becomes move. Okay. Try that. Remember when I was like, yeah, let's choose an easy task. I guess it's not too bad. We do have it working. We're just handling all the fun edge cases. The balancing act of combining C++ enclosure semantics is impressive. Thank you. Yeah, it's a hoot. Okay, so those all pass. And then jank run, so deleted move. Oh, but this fails with code gen. Okay, so that's not good. And then deleted copy and move also fails with code gen. So we're right back where we started. But we're close. We're not quite where we started because we're close. We're just not there yet. So if it doesn't have a simple copy constructor, and also I'm going to change the name of this because simple, we're not dealing with simple anymore. Has copy constructor has what about usable? Because all we care is that it's either simple, meaning it's sort of implicitly defined, and it's not deleted, or it is user defined. So we're gonna, or it is like user defined and it's not deleted. So let's do simple. Simple becomes usable. Okay, so let me verify that the scope that we have is good. I want to dump the scope, arg scope. Now I said this can be nil, so I want to check this only if, actually it can be null, so I want to check that only if it's non-null. In our case, it should be non-null. Clang crash. I think Cling just crashed because we were changing the file while it was compiling. So it just re-triggered the compilation. In case you're wondering, not actually a concern. All right, there we go. So yeah, this is the dumped scope. This, if you're wondering, oh, that looks very similar to the AST that we were seeing in Godbolt. Well, that's very observant of you. It is in fact the same thing. This is what dumping the AST looks like for Clang. Does jank have a similarly nice AST dump? No, it does not. Okay, so we do have a scope. We do have nice IR printing. You're right. I do like our IR printing. But yeah, I don't have anything good for the AST printing. Yet. So if we take the case where we don't have this, yeah, so that's this one. We have a deleted move and a deleted copy constructor. I think we got to whip out the debugger on this one, because I don't know why that's not working as expected. Hey Tyler, we're working on the compiler for the jank programming language. Okay, and then we dump, and that looks good. Yeah, so let's take a look in here. So has usable constructor. So we'll see. Has simple constructor is, so this should be false. And it is. And then, or has user declared copy constructor, which should be true. And it is. And not default copy constructor is deleted. Which this should return true, and it returns false. And so this is the problem. This function is not giving us what we're expecting right here. Let me run this again. Uh, 13, 18. So I can't print that, unfortunately. But it doesn't matter, because we can see when we return here that we get false. Defaulted copy constructor is deleted. This must not be exactly what we want. Because we are, in fact, deleting the copy constructor. We are deleting the copy constructor right here. But I suspect that it's something around the defaulted copy constructor. If a defaulted copy constructor for this class will be deleted. Yeah, I don't think that's right. I think that default here means like implicit. And so I think that they're trying to, this is trying to convey that if you would otherwise have a copy constructor that would be deleted for this. For example, if you have any of your members that are non-copyable, then you're not going to get a default copy constructor for your composite type as well. So I think it has a similar name to what we want, but it's not actually the right thing. So I think what we're going to want instead is if we have a user declared copy constructor, we probably need to get a handle to that user declared copy constructor. I wonder if this already takes into account the deleting. And then we're into other stuff. Has trivial default constructor, has non-trivial default constructor. Look up constructors. Force declaration of implicit members. Look up constructors. Look up default constructor. Look up copying constructor. Look up moving constructor. Quals. We might actually want to force the declaration of implicit members when we try to check this in our own code. Yeah, so the thing about the Clang API, right, is that there are no docs for it because it's not a public API. This is just the internals of Clang. And so there's just a lot of figuring out what's going on and how things piece together, and it's a mess. This is why there are not many languages that have C++ interop. It's this right here. Okay, so I think let's just simplify this, and we'll say, okay, if we have a simple copy constructor, then we'll just return true. And then otherwise, we'll say, okay, if we have a user-defined copy constructor, I want to test this. So first, I just want to see if this behaves well. because I don't know if it's gonna, if it's automatically deleted, I don't know if it's gonna count as having as being user declared. I assumed that it would be user declared, and then we'd also have to check if it's deleted, but we'll see. That's why we have the tests. Okay, so let me just check what we're doing here. Yeah, if we don't have this and we don't have this, and this is deleted copy constructor, deleted moving constructor. Yeah, so that means that I was right, that it is user declared. This is giving us true, but we need to check if it's deleted or not. And so look up default synthesizing code RAII. What the fuck is this? This doesn't do anything. All right. So what we're gonna do is we're in move constructor right now. Look up moving constructor. Right, so this takes quals. I don't know what the quals are. Like, I understand that they're qualifiers of some fashion. This quals. All right, so this is where we jump on to GitHub. Oh, I hope I'm logged in, because if I'm not, then GitHub doesn't do code search. I'm not. All right, I'm gonna have to do this outside of the stream window. Look up moving constructor. Okay, so there's a K no qualifiers. That's just 0. Constructor is accessible. Is deleted. Okay. So yeah, I think we can just specify 0. And that should be fine. So let me jump back into here. 0 is deleted. All right. Cool. Let's see. Okay, so that fails that one, which is good. And this one does not fail, and that's okay because we didn't cover that yet. And all of the passing ones pass. Good. So now we just have the one failure, which is that special case of we have a copy constructor, but we have a deleted move constructor. So we have these two cases. We either have no usable copy constructor and no usable move constructor, or, ooh, does this go both ways? I bet it does. Okay. Just so I don't forget. But we'll handle the case that we have now. So we'll have an or. The or needs to go this. And so for this, we have a has usable copy constructor, argscope, and CVP has deleted move constructor. So right now I'm just giving the same error for both of these. We can clean that up. Mainly I just wanted to make sure that it errored. So I want all of the ones that pass, that should pass to pass, and then I want all the ones that should error to error, and then we can make sure that we get good error messages for both of those. Cool. So all the ones that should pass do pass. And then this guy still does not fail properly. And this guy does fail properly. Okay, so this one has a deleted move constructor. I'm going to remove that scope dumping, by the way, because it's not helpful. So for this, we have a default copy, and we have a deleted move. So I'm expecting... All right, let me pull these out. Okay, so if it has a usable copy constructor and it has a deleted move constructor, And if this doesn't work, then we can step through it with GDB, because this feels like it should. I think I'm going to go refill my water, use the restroom. Give me a couple minutes. Be right back. Hey, it's me, Ghost. Welcome to the stream. Hope you're doing great. Thanks for holding down the fort while I was gone. I got some more water. I also already had a protein bar here. Let me get some more food in. What's everyone up to? So this did not work. We can jump in and so we're gonna get past here. This is the one that we care about. So has usable constructor, copy construct. Oh, no, that's right. because we want the usable copy constructor and the deleted move constructor. You need to finish those AOT jank tests. Yeah. Is that something you're dreading, DJ Blue? Or is it just something you haven't gotten to? How the bash test suite works, or how the AOT tests in particular work? Is it helpful for me to go over any of that right now? We don't have to, but if it's helpful for you to see that, then I don't mind doing that. Yeah, it would be nice to finish this. I'm gonna finish my protein bar first. Not affiliated at all. I really like these. Cliff bars, but they're like Cliff Builder bars. All right, refueled. Let's take a look. So has usable copy constructor should be true. Let's take a look. Has simple copy constructor? No. And then, yes, true, good. Moving on, has deleted move constructor. Ah, right. I think we need to update these. Because this is going to be false. Right. So what for deleted, what we actually want is we want to check if it's user declared. And then we want to check if it's deleted. I think it's odd that these functions call it a move constructor. These functions call it a moving constructor. Just made my search and replace a little more annoying. All right, cool. So now we just recompile those. I feel good about this. But it does mean that we would need to handle another case because of this goes both ways. We'll see. All right. Cool. So that fails since its move constructor is deleted. And then both being deleted, it's neither copy constructible nor move constructible. And then all of the pass tests pass. Perfect. Now the to-do here for going both ways is because if we have so this is if we have a usable copy constructor and a deleted move constructor. But what if we have a usable move constructor and a deleted copy constructor? So let's take a look at that. So we have a usable move constructor and then a deleted copy constructor like this. This passes. Because it's going to move by default. Yeah. So we just want to cover that case as well. So let's do ooh, this naming is not updated. This should be fail native value deleted move CTOR. Fail native value. There we go. Let me grab that other fail one here because yeah. Pass native value deleted copy CTOR deleted move CTOR. Yeah. Okay. So if I yoink this and we make one more, this should be our last one. And so this is going to be a deleted copy CTOR default move CTOR. And so this is going to be delete. This is going to be default. And then pass native value deleted copy CTOR default move CTOR. All right, and then that one should work. So we should see 4 of those now. And yeah, all those work. And then our 2 failures, this is deleted both, and then this is that one deleted. Nice. Cool. And so now the final thing is 2, 3, 4, 5. Final thing is just run the whole test suite. Make sure we didn't break anything else. Yeah, the the trickiest thing about this was not implementing the feature, right? The trickiest thing about this was handling the various edge cases for like deleted and defaulted combinations of copy constructors and default and move constructors. So I see we have a failure here. Pass finally behavior, interesting. Yeah, and like none of those things seem like they're directly even related to the throwing, you know, that we were doing. So fails after. Yes. I thought about this as we were implementing the throwing of native values. So basically right here, we're throwing a string now, and this is going to be a C string. And so we have to make a decision here. Should this automatically promote to an object because it's a literal that can be an object, you know, that can be a persistent string? But if we do it for strings, then that means we'd have to do it for integers and bools as well. I'm on the side, I think, of saying that these are native values and we should just treat them as native values. And if you want to throw a boxed value, then you should box it first. Right now, the best way to box something is to just pass it through identity. Maybe we should add a box function that is the same as identity. But yeah, for now, I'll just box that string. And that's that. So there were two parts that we wanted to tackle. And this was the bigger one. The other one was the rethrowing of current exceptions, which in C++ you can do by just having a throw expression without an argument at all. Just throw and then semicolon. So in jank, similarly, we could just have a throw expression that doesn't take any argument at all, and then its job would be to rethrow the current exception. So for that, all we should need to do is just make the argument optional for throw. The catch here is if you try to rethrow an exception and there is no active exception, then what C++ will do is it'll just terminate the program. I'm wondering if we want to do something better. Because I think we could check if there's an active exception. I believe that we could check for exception putter. And I think that this will give us back null if there is no active exception. What's the difference between throwing the active exception and throw E? Nothing, as long as you have E, but you don't always have E. So in the case of a catch all, which is the catch ... right here, you don't get what, you don't have a handle to the current exception. And so that's when you use the current exception function here, and that gives you a handle to it. And then you can then rethrow that, or you could just do the empty throw expression inside of this catch ... and it'll just rethrow the current exception for you. So yeah, current exception, an instance of exception pointer holding the current exception. So throw is throw current exception. Yes. Yeah, maybe we don't even bother supporting that syntax. Like maybe. Also, I don't know if there's an exact difference between throw on its own and throw current exception, because there is rethrow exception. Yeah, I think that if you want to rethrow, you have two choices. So I think that you have either the empty throw expression, or you have a call to rethrow exception with the current exception. But I think that if you throw the current exception, then that's different, because then you're creating a new throw, and the exception type is like whatever the pointer to void is, the opaque pointer that you get from current exception. Rethrowing. Yeah, they don't actually, CPP ref doesn't provide much information on rethrowing. It just says like, yep, rethrows. But the current exception, does this give us null pointer if there's no exception? If the function is called when no exception is being handled, an empty exception pointer is returned. Okay. And an exception pointer is some unknown thing, but it's nullable, pointer-like. Default constructed is a null pointer. Okay. Okay, yeah, so we can check if there's an active exception. Yeah, so what I'm thinking is also test passes, so that's great. Yeah, I was thinking like if we have Yeah, don't worry about that. So if we're here and we just try to rethrow, right? Clang foo. Then we just get like terminate called without an active exception. If we godbolt this, so let me jump into here and delete all this and then just do a throw. I don't care about the AST anymore. So let's just grab this and output be down here. Actually, I don't care about the output. So this ends up calling the C++ ABI like CXA rethrow. And CXA rethrow is going to, why the fuck can't I select this? That is blowing my mind. So basically, this rethrowing existed in C++ right here. This existed before the addition of this exception pointer. Exception pointer was added in C++ 11, same with current exception, everything like that. Whereas the ability to just rethrow the current exception has existed since, I think, C++ 98. Yeah, it's not even tagged here, so it's the OG functionality. And so being able to get the current exception as a pointer is a relatively new thing compared to just being able to rethrow the current exception. I think my only thinking here is like, we can support the empty throw expression. That's going to be relatively straightforward. I'm just wondering if we want to be a little smarter about it. So that way, if you try to rethrow, if we can code gen in some code that looks to see if there's an active exception. And if there's not, then at least we show an error with a nice sort of source snippet that says, right here you threw, there's no current exception, everything like that. Maybe we won't worry about that yet because I'm still sorting out the runtime errors and source information and everything like that. And maybe that will just be automatically solved. Okay, fair enough. I talked myself out of that. So let's just add this rethrowing in, do the analysis, do the IR gen, do the code gen, and then see if we can get that done. Okay, so we start by changing the analysis. Throw doesn't require exactly one argument anymore. Throw requires, so count has to be less than 3. Throw requires exactly 0 or 1 argument. 0 or 1 arguments. 0 arguments. 0 arguments or 1 argument. 0 or 1 arguments. I don't actually know if I put an S here grammatically. I'm going to put an S. It sounds colloquially more appealing. So now that means that we need to deal with the case of no arguments. And so we'll say if count is equal to 1. Throwing without an argument just rethrows the current exception. This can be done anywhere, not even with just within a catch. Yeah, and then I think we'll just make our throw and early return here. For 2944, that's the opposite. If, right, it is, you're right. That is a good catch. So what we really want is if do we want to check if it's not equal to 1, not equal to 2? Or just greater than equal to 3? So 1 is throw, 2 is throw with an arg. Yep. And then here we're going to put no argument. We're going to have a constructor that takes that. So we'll have expr throw. Takes no value. And then this will be a JTL option. So this has no value. World doesn't need a jank programming language. World doesn't need any more mean people. Why be mean? Even worse, why be mean and then be muted? We need to do something about this. Actually, I don't know if we do. Maybe that'll work. Okay, so that's our analysis, let's say. Now, for throw here, type value. I swear I have a struct somewhere for like typed identifier. I do. I'm gonna use one of those. So we'll do a JTL option of a typed identifier. So we have unwrap. This gets a little messy. I don't really want to do an unwrap or. So we're just going to break this up, I think. No, we'll do a ternary. So if it is sum, then value unwrap name. And then we'll do a similar sort of thing here. What do I want to put there? All right, and IR builder throw value. So we want a throw that doesn't take anything. Oh. Could have an if for both branches and what? You mean in the print? I just didn't want to break up the formatting into two places, and so I settled for doing two ternaries. That's just laziness. Okay, so we're gonna have compiler errors in a few places because of this. Oh, typed identifier. This is detail. So here we'll do if expr value is sum. And value unwrap get type. Is JTL option a wrapper over standard option? No, it's a replacement instead of standard option. Standard option is not well designed. Main reason being if you deref a standard option that doesn't contain anything, you get undefined behavior. Wait, why do they do that? Yeah. Yeah. All right, now we're just fixing errors in the various places. Sure, that's the formatting I wanted, yeah. And rewrite. Haven't been in there. Throw. This is IR, so this should be name. No template option. Okay. Our walk. Okay, so this doesn't work. Unwrap, or this is an expression. I can't really do that. I actually don't even. I can clean this up. Oh, I already have a member called value. I just need to call that V. There, V will be there. And then IR walk. All right, maybe. eval. So if expr values sum, throw, else, throw. Oh, I mean unwrap. All right. There we go. God damn. So now we should just be able to throw, let's just try to rethrow like so. That was supposed to be test.jank. Cool. That looks good. Take a look at the code gen. Yeah, code gen's just a throw. That's good. And tests for this one will be much, much simpler. All we need is jank cbp throw. All we need is a rethrow. And we don't even need to rethrow a native type. All we just need to do is rethrow. So let's throw a 1 and catch a catch an int. And I'm just trying to model how I want this to look. Catch jank runtime object ref. I'm gonna throw success. Then I'm gonna catch it. I'm going to throw it as a string. And then, oh no, I can't change it. How do I want to do this? I want to verify that I caught it once and then I rethrew it. Hey Jay, what did you do today? I didn't have much time to catch a stream. Oh, it must be late for you, Johnny. Today we implemented support for throwing native values from within jank. So we had we had the throw expression done, but we were only able to throw jank objects. We changed that so now we can throw native values. But there were some real gotchas with that because the way C++ works, it can either throw a copy of a value or a move of a value. And depending on whether or not you have a copy constructor or a move constructor, you may not be able to throw that value. And so we actually spent the majority of the time on that feature just in Clang internals, trying to figure out how we can assess all of the correct bits to determine what we can throw and what we can't. And then the last thing that we're implementing right now is the ability to rethrow an exception, which is just a throw expression like this without any argument at all. And what it does is it rethrows the current exception. And so we've just implemented that, and now we're writing the test for it. And then once the test passes, then we're going to be done. So I am going to throw the keyword, but I'm also going to add a let with an atom, I think. So in here, I'm going to reset the atom to true. And then here, I'm going to check if inner catch, then evaluate to that. So here we should get our success. So we have an inner try, we throw, we catch it here, we reset our atom to true, then we rethrow. Then that will catch that here. If our atom is true, then we do our print line. We should see success. Pass, rethrow. We do. So if we just remove that and then go back up, run the whole test suite. If this works, then I think we're done. Actually finished on time. Who would have thought? Yeah, as we get closer to closure conj, there's only, I have to be even more prescriptive with my time because there's a lot that I'm trying to get done before the conj that I want to include in my talk. And so I mentioned how I wasn't going to be working on the error reporting stuff today on stream because it's too exploratory, and I don't know. I don't think it's going to be super interesting. Oh no, fail with no value, terminate called without an active exception. This is the one that we just wrote. Wait. Oh, fail. Oh, this is an old test. This is an old test that says that we should fail if you call throw with no value. So this test gets deleted. Nice. Yeah, I was saying how I didn't do this error reporting stuff on stream because it's just too exploratory. I think as I figure out more about how it's going to work and prove its viability, and have like clearer, more concrete work that I can do on stream, then I'll be doing more of that when we're actually on stream. But to start with, when I'm still just trying to figure out like the Clang APIs. Like I already did a lot of crawling through Clang APIs today on stream. The error reporting stuff is going to be a lot of that. And it's not something I want to do on stream. So fortunately, I have these other smaller things that I just need to get done anyway. Like we need to be able to throw native values when you're porting C++ code to jank code. That's just going to be important. And rethrowing exceptions, stuff like that. And it's relevant to the error reporting, the runtime error reporting stuff. So there's still a lot of just small bits and bobs that have to get done anyway. I may end up just picking up those tasks if I'm not ready to do the exploratory work on stream. But yeah, once I am ready, then I won't keep hiding it. I'll show you guys what I'm in the middle of. But that's it. We did it. We did both things, and we did it all within the stream before I fell asleep. Done. And then, as I said, I'm not going to do the catch-all until the core team and other dialects come up with a common syntax that we're all going to use, hopefully. Or at least come to an agreement that we're not going to have a common syntax, and then I can do whatever the fuck I want. Which is probably just going to be try to find like the most common thing among the different dialects and use that. But anyway, I think Kuvi is online. He's another compiler dev, so I'm going to shoot you guys over to him. He's working on a programming language called Cast, which is super cool. So let me shoot you guys over. Thanks for hanging out. It's been fun, and we got a lot done as well. So let's head on over to Kuvi and say hi and see what he's up to. Thanks, folks.
Yo, Jay Wilkerson is here. Hello, and thank you for the raid. How's jank going? Jay Wilkerson is also making a programming language. It's called jank. If anyone else is looking for another like developer of a programming language, I really like the streams of Jay Wilkerson. I forgot that you streamed today. I would watch instead maybe of streaming then. Instead of working, I could just relax, you know. You had a great stream, nice. Okay. I am transpiling to C, and my C transpiler has finally started working like yesterday. And I'm going through examples and making sure that everything works. There's some bugs and everything. And right now I'm doing like something very simple, which is compiling the lists. So I have a list and it's implemented now. So this is an array list or a vector. I don't know what you call them in jank. Do you call them vectors or not? I hate the name vector. Yeah, I hate the name vector because I'm like when I'm making a game and there's like a 3D vector which is completely different than like the vectors which are global arrays. Anyway, what kind of language is Cast? It's supposed to be like a very powerful programming language, which is like of all kinds. I don't know. How do you describe the language? What kind of language jank is? I don't know. It's okay. It's a language. Yeah, it's not a Lisp dialect, right? You can see over here. This is the code. We have mutable variables, right? it's more like Rust combined with like Haskell. There is some Lisp features, but I'm not using the Lisp syntax, and also I'm going for like the effect systems. The so like in short, it's a combination of Rust, Haskell, Lisp, and Coca, I guess. Maybe that's like the shortest thing that I can tell you. The effects are not really implemented yet. Like that's what I wanted to do after the C transpilation. Basically, I want to decouple the algebraic effects into the delimited continuations and the and like the context system. Instead of having algebraic effect